This is chapter 12.5, Law of Cosines. We've already used Law of Cosines, which are used with non-right triangles. We've already used Law of Cosines to find side measures. Now we're going to find angle measures. So if you please turn to page 676, example 2 in your book, you're going to see this particular problem. So draw the triangle ABC. Label the A side 5, the B side 11, and the C side 8. Make sure that your angles are directly opposite those sides. So angle A has to be directly opposite A equals 5, angle B has to be directly opposite B equals 11, and angle C has to be directly opposite C equals 8. Okay, you're going to be finding B. That's what it says in the directions. Now, there's definite differences between the way I'm doing this and the way the book is doing it. Neither is incorrect, but I think you'll have more success because there's a few more steps involved in the process that we're going to use together. Okay, so the first thing, you want to find angle B, which means that your B squared is going to be outside. And that's going to coincide with cosine B. So again, we talk about those patterns. If you're finding B, if you're finding angle B, then it's going to be B squared. B squared equals A squared plus C squared. That's your connection to the Pythagorean theorem. Here's a constant amount, minus 2. Cosine's also a constant amount. And then whatever these two amounts are here, this A and the C, is what you're going to put here, AC. Now we're going to simply, that's your formula, that's how you remember it. You don't have to memorize 3 different formulas, you just use those patterns to help you. So we're going to go ahead and, B is 11, so 11 squared, A is 5 squared, C is 8 squared, so plus 8 squared, minus 2 times 5 times 8, cosine B. Now so far everything's fairly simple. 11 squared is 121. Again, you don't need a calculator for this, so please don't use it at this point. 5 squared is 25, and 8 squared is 64. Now here's where you have to be careful. You've got minus, and then 2 times 5 is 10, times 8 is 80, minus 80 cosine B. Because subtraction always tends to cause little problems, I'm going to change this to plus and negative. Just put it in parentheses so it's easier to see. 80 cosine B. Now, at this point is where if there's going to be an error, it would be made here. So you can't add 25, 64, and negative 80, or you will miss it, because multiplication comes first. So you got to put this together. This has to go together here. Now, if you think about a problem like 2x, and we'll just write it somewhere up off to the side, I'm going to use a different color. If you think about a problem like 2x plus 5 equals 30, you know that the very first thing you have to do is subtract 5. Well, it's going to be the same thing here. We're going to get 25 and 64, which is going to be 89. So we have 121 equals 89 plus negative 80 cosine B. And again, I'm going to keep that in these brackets to keep it all together. So you're going to treat it like this. 2x plus 5 equals 30. The very first thing you do is subtracting 5 to isolate the 2x, because your goal is to get to x, whereas here our goal is to cosine B and then finally B. So we're going to subtract 89. Which is 32. And then I don't need the brackets anymore. We're just going to go negative 80 cosine B. Now you use the subtraction property of equality when you subtracted 89. Now you're going to use the division property of equality. You're going to divide by negative 80. (32) divided by negative 80, division property of equality is being used, is negative 4/10. And that number doesn't usually come out to be a single digit. It usually has to be rounded 4 digits after the decimal to the 10,000th place. And then cosine B. Now we're almost there. Here's where you have an additional step. You're looking for B, so you got to get rid of the cosine. The inverse operation for cosine is cosine negative 1. That's inverse of cosine. And cosine negative 1 are inverse operations. It becomes 1. And you're left with B. Whatever you do to the right side, you have to also do to the left. So you're going to do cosine negative 1. And so you're going to put it into your calculator. Hit your second key. Hit your cosine key. It'll say cosine negative 1. Then type in times negative 4/10. And you'll come up with your angle measure. The book is rounding to the 10th, so let's go ahead and do that as well. Okay, and so then you end up with B equaling 113.6 degrees, and it's not exact, it's going to be an approximation. Let me fix that. All right, now we're going to move on to the next one. I'm going to get you started on this one, but you're going to do most of it. So we're still on the left side of our paper taking notes. Okay, and so this is also on page 676, checkpoint. And in this one, it asks you to find C, and then it says it's all given in words when A is 3, B is 7, C is 9. Now we need to draw a picture of this, because when you're testing, I'm going to give you some that are just words, and then some that have pictures. So label your triangle ABC, just draw any old triangle, just try to make sure it doesn't look right, because law of cosines is used with non-right triangles. Make sure your A is opposite your side of A equals 3, that your angle C is opposite the side of C equals 9, and that your angle B is opposite your side that equals B equals 7. Okay, now again, we're finding C. That's what the problem is asking for. So we're going to go ahead and put cosine C, which means you got a C squared out in front. Again, always going back to this pattern. Now we go back and connect to the Pythagorean theorem, so C squared equals A squared plus B squared. And again, we're going back to the pattern. This A and this B are going to be coming in right here. But first you have a constant of -2, and then it's going to be AB. So there's your pattern. And now you just substitute C into the C spot, A into the A spot, and B into the B spot. I want you to try the whole problem. Make sure that you show all the inverse operations, the properties of equality correctly, and then when you're finished, I want you to turn it back on and check your answer. Okay, so we substituted 9 for C, 9 squared. A is 3, so 3 squared. B is 7, so 7 squared. Minus 2 times 3 times 7 cosine C. Again, no calculators needed at this point, so I'm going to encourage you to use your brain. The calculator up on the top of your shoulders. So 9 squared is 81. 3 squared is 9. 7 squared is 49. 2 times 3 times 7 is 42. I'm going to change subtraction to addition using the additive inverse, so plus a negative 42 cosine C. Notice I've grouped the negative 42 in cosine C. Remember, color helps your brain. If you don't have color, you could bracket it like I've done. You add 9 and 49, which gives you 58. Subtract 58 from both sides using the subtraction property of equality, which leaves you with 23 equaling negative 42 cosine C. Again, we're trying to isolate C, so our first property of equality, our next property of equality is going to be division property of equality. Divide both sides by negative 42. Now in this instance, you get a big long number, but if you were to round it to the nearest 10,000th, or the 4 digits past the decimal, you get negative 0.5476. You want to just get C, so you have to take the inverse of a cosine, which is the inverse of a cosine is cosine negative 1. You take that to both sides, and you end up with 123.2 degrees. Make sure you put the degrees on. 123.2 and 123.2 degrees is different, and that's going to be approximately C. Okay, now where this differs from where we did the law of cosine, where we found a side measure, now we're finding angle measures. When you found a side measure, it was side angle side. When you find an angle measure using the law of cosines, it's always going to be side, side, side. Now that's not hard in this one because they're all going to be side, 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 but you need to start thinking about that, because when you have law of cosines and law of sines mixed together, where you're finding either angle versus side, you're going to have to be able to differentiate or tell the difference between which property you're using. In this case, it's side, side, side. Now let's go back up and look at the first one. Example 2 from page 676. I know in your book it says side, 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 but again, you can see side, 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 8, 5, and 11. So this is also side, side, side. So just need to pay attention to that and be able to tell the difference between them. Okay, now your assignment is page 678, 5 through 7. We're going to get started on 5, so we only have a portion of 5 to do. The reason we need to do 5, and one of the the troubles with your book is in all the examples, including the checkpoint activities, they use ABC triangles. Well, if you look at 5, 6, and 7, they don't use ABC triangles. In this case, they have a PQR triangle. Please take a second, pause the recording, draw it, fill in all the appropriate amounts, and then write that you're going to find Q. Okay, it asks you to find, it doesn't say find Q, it asks you to find the value of X, and that's why they put this X degrees right here. So they can ask it in several different ways. Again, this is going to be side, side, side. And you can see, because you've got 10, 22, and 16, again, you're finding an angle measure, you're finding angle Q. But here's where you have to be careful. ABC goes in alphabetical order, so you have to match up. So you have A, B, C in alphabetical order, so you have to match up to the alphabetical order of this triangle, PQR. And then you're going to use that. So we're going to say, okay, Q matches up with B, so we'd be finding B squared. I'm going to start with my original formula. B squared equals A squared plus C squared. Okay, there's the Pythagorean theorem. Minus 2. Then I've got this AC. And then the next thing that's constant is the cosine. And you're finding B, so it would be a capital B. And then you just substitute. Well, B is going to be Q squared. A is going to be P squared. C is going to be R squared minus 2PR. And then cosine B, or cosine Q, excuse me. So again, let's take a look at, you've got this pattern here. So the Q matches up with the Q. And then we go back over to this one. The P and the R match up with this PR. Again, minus 2 and cosine are constants. Okay, from here, just substitute values. Do exactly what you've done in the others, using the law of cosines to find angle measures.